Hello everyone, welcome to the lecture on experimental research. The objectives for this lecture, for this chapter, by the end of it, hopefully you'll have a better understanding of what experimental research is and how it's conducted. You'll know the threats to validity, both internal and external, and how to control them. That you'll recognize the types of designs commonly used in experimental research, and you identify common errors of interpretation in research findings. I'm going to break this lecture down into two parts, mainly because I've been having some problems with the recording software, and rather than record a whole lecture and then lose it, I want to break it down into two parts so I at least get halfway through. So, experimental research. It's a traditional type of research that is conducted in most disciplines. It's virtually the only type of research performed in the hard sciences. In all cases, experimental research is conducted to increase the body of knowledge in our discipline and to suggest what procedures should be followed in the future. The book gives us a nice example in their opening paragraph. They say, "A researcher who compares the effectiveness of two or more teaching or training methods, drugs, or techniques is trying to determine if there is one that is best and should be used in the future. The scientific method is discussed," we already did that in chapter 1, "and is always followed in experimental research. Finally, experimental research always involves manipulation of the experimental unit, which might be the human participants. Consider the typical methodological study where each group of participants receives a different treatment. The treatment received by a participant has a potential to change the participant. Isaac and Michael in 1995 stated that the purpose of experimental research is to investigate cause and effect relationships by subjecting experimental groups to treatment conditions and comparing the results to control groups not receiving the treatment," as stated on the slide in front of you. So this is kind of trendy types of research, and previously in this course most students have come up with some kind of experimental research study for their proposal, where you want to put people into different groups and you want to try different treatments with those groups to see what works the best. So the outline for this lecture, we're going to talk about procedures in experimental research. We're going to review internal and external validity and threats to those. We're going to begin to look at some types of designs, experimental designs, talk about methods of control, and common sources of error. So there'll be two videos for you to watch, video lectures for you to watch. This is the first one. I've also embedded 6 YouTube video links within this lecture that I would like you to watch. 4 of them I'd definitely like you to watch. 2 of them are optional based on how comfortable you are with that content. Those links are in this PowerPoint, but I've also put direct web links on Blackboard, so you can just click to those at the necessary points in the lecture. So when you get to those, stop the lecture, go back into Blackboard, click on those links, watch those videos, because they're inserted into the right place for the progression of the lecture. Of course, you could decide not to watch those YouTube videos. However, I don't think you're going to understand this content as well as you would do if you did decide to go ahead and supplement this material with those YouTube video links. So we're getting into the fun stuff now, because you're going to use this information to design your own proposal. So the first 2 video links, the first one is a review of variables. In fact, they're both review of variables. We've looked at this already, talking about independent and dependent variables. Independent variables are those that you're in control of, that you manipulate to see how they change the dependent variable. So go ahead and watch either one or both of those at this point to review those variables. Okay, hopefully you just watched those two review videos. So let's talk about experimental research and provide an overview. Like I previously said, experimental research is a traditional type of research and the only type of research conducted in the hard sciences. The purpose is to investigate cause and effect relationships amongst variables. So here we're talking about experimental groups versus control groups, where each group of participants receives a different treatment, and we're manipulating the independent variable to see the effect on the dependent variable. And within the independent variable we might have multiple levels, which is usually how many different groups there are in our study. As stated a couple of lectures past, experimental research answers the question what will be, as opposed to what the questions are being answered for descriptive and other types of research. Research validity. Defined. Internal validity refers to the validity of findings within the research study, the technical soundness of a study, and we're particularly concerned with the control of extraneous influences that might affect the outcome. And we'll look at this as we move through this lecture. External validity refers to the degree to which the findings can be inferred to the population of interest or other populations or settings. It refers to the generalizability of the results. Can we generalize our findings in our research study to other groups and other situations? If we control the threats to external validity, then we can say with some kind of confidence that we can do that. Both are very important in a study, but they are frequently at odds with one another in planning and designing a study. There's a trade-off going on. Sometimes the more you control internal validity, the more you control extraneous influences and variables, that takes away from external validity, the more you can generalize it, and vice versa as well. For example, if we pull people into a highly controlled lab setting where we control all of the extraneous variables except for the independent variable that we're manipulating, then it's hard for us to generalize those results to real-world situations. Internal validity is considered the basic minimum for experimental research. So you could have a good study with good internal validity and not so good external validity, but you definitely cannot have a good study where you have poor internal validity and good external validity. Internal validity is kind of one of those things where you don't pass go unless you take care of those things. External validity doesn't matter if you don't have good internal validity. So internal validity is particularly important in experimental studies. We're asking the question, did in fact the experimental treatment, which we often call X, produce a change in the dependent variable, which we often call Y? And to be able to say yes, we must be able to rule out the possibility of other factors producing the change, other factors other than the independent variable that we are manipulating. To gain this internal validity, the researcher must attempt to control everything and eliminate possible extraneous influences. This in itself lends a lot of research to be conducted in highly controlled lab settings. This is old. Campbell and Stanley in 1963 presented 12 factors that can threaten the validity of an experimental research study. And even though it's old, this is still reported in every research methods textbook because it still holds true. threats 1 to 8 threatened internal validity, and 9 through 12 threatened external validity. And what we do is we try to control as many of these threats to internal and external validity as possible ahead of time. So let's look at each of these individually. Threats to internal validity. Number 1, history. History refers to specific things that happen while conducting the research study that affect the final scores of the participants in addition to the effect of the experimental treatment. Suppose that participants participate in an activity or program outside of the research study, but that this activity is very similar to the experimental treatment. If this outside participation increases their final scores, it makes the experimental treatment seem more effective than it really is. A second example of a history threat to internal validity is an atypical occurrence, such as an epidemic, local disaster, or one-time emphasis on the research topic in the community that occurs in the lives of participants during the research study and that affects their final scores. So any events occurring during the experiment that are generally not part of the treatment. The second threat to internal validity is known as maturation. Because participants grow older during the experimental period, their performance level changes, and this change is reflected in their final scores. For example, as young participants grow older during the 15-week experimental period, their physical performance level changes no matter what the effect of the experimental treatment. Similarly, as elderly participants grow older over the course of a 6-month fitness program, their physical performance level decreases no matter what the effect of the fitness program. Seasonal changes might also be considered under this threat to internal validity. For example, between September, when the research study begins, and December, when the study ends, participants become less physically fit due to less daily activity because they are in school all day and the weather is bad. This loss of fitness counteracts the effect of the experimental treatment. A control group receiving no treatment can be an effective check on the maturation threat. So this is the biological or psychological processes within participants that may change due to the passing of time. The act of taking the test can affect the scores of the participants on a second or later testing. For example, participants are pre-tested, then the experimental treatment is administered, and finally the participants are post-tested. One reason why participants do better on the post-test is because they can learn from the pre-test. The pre-test acts like a treatment. This poses a problem if the pre-test and post-test are the same knowledge or physical performance test, if the tests are the same. Baumgartner, who wrote our textbook, tested participants with several physical performance tests and then retested them 2 days later and found that scores had improved from the initial test to the retest without an intervention in the middle. So the effects of one test upon subsequent administrations of the same test is known as the testing threat to internal validity. And there's things that we can do to control that and these other threats that we'll look at as we move through this. Changes in the adjustment or calibration of the measuring equipment or of different standards among scorers may cause differences among groups in final score or changes in the scores of participants over time. So if we're using a bod pod or a DEXA scanner or scales, we need to make sure those are calibrated regularly and are accurate in what they're measuring. Also, if we have more than one person acting as an observer and collecting data, whether it's a survey or an interview or some other kind of data collection, we need to make sure that those people are well trained and we have good inter and intra-rater reliability to make sure that they are recording and scoring things the same. If they don't, or if the machinery or equipment is not calibrated, then we call that a threat, the instrumentation threat to internal validity. Statistical regression is the tendency for groups with extremely high or low scores on one measure to score closer to the mean or the average score of the population on a second measure. That's called statistical regression. Selection bias. The way participants are selected or assigned to groups can be biased. We've looked at that in the last lecture. This may result in groups that are not representative of a population and groups that are not equal in ability at the beginning of the experiment, or groups that differ at the end of the experiment for reasons other than the differences of the integrity of the experimental treatments. Random selection of participants and random assignment to groups usually controls this threat. Experimental mortality. This particular threat to internal validity is created with the excessive loss of participants so that the experimental groups are no longer representative of a population or similar to each other. Number 8, interaction amongst factors. This basically says that any of these factors can operate together to influence experimental results. A common one or common threats that interact together are selection and maturation and history. External validity. This deals with the generalizability of results. To what populations, settings, or treatments variables can we generalize our results to? Here we're concerned with real-world applications of the results of our study, or asking the question, what relevance do the findings have beyond the confines of this experiment? We generally control external validity by selecting subjects, the treatments, and the experimental situations, and test to be representative of some larger population. And random selection is key to controlling most threats to external validity. We talked about in the last lecture about the word randomization being a magic word in sampling participants. So let's briefly look at some of these threats. The interaction effects of testing occurs when the pre-test changes the group's response to the experimental treatment, thus making the group unrepresentative of any particular population and certainly unrepresentative of a population that has not been pre-tested. So the fact that the pre-test may make the participants more aware or sensitive to the upcoming treatment. Selection bias. The participants or groups selected in a biased manner react to the experimental treatment in a unique way, so they are not representative of a particular population. Reactive effects of experimental setting. This is where the experimental setting is such that the experimental treatment has a unique effect on the participants or the groups that would not be observed in some other setting. And we often see this when our research is conducted in very controlled lab settings, and we wouldn't see the same thing if it was done in a real-world situation. And then multiple treatment interference is when participants receive more than one treatment and the effects of previous treatments may influence subsequent ones. So the four threats to internal validity are a little bit harder to understand than internal validity, and I'm not saying they're not important, because they are, because if we don't take care of these we cannot generalize our results. But I will say for an undergraduate research methods course, our focus needs to be more on controlling threats to internal validity. So, in general, some generalizations here. Too much control can harm external validity, but not enough control can destroy our internal validity. And I think at this point Actually, I'd like you to jump out and watch video 3, which is the same information I just presented in a slightly different way. So this would just help you to understand it with another voice. And when you've completed that, that's 21 minutes long, come back to part 2 of this lecture, where we'll start to look at some different types of experimental designs.